So this is a question from IIT JEE PYQ. The question is from the chapter Newton laws of motion. The question is two particles of mass m each are tied at the ends of a light string of length 2a. The whole system is kept on a frictionless surface with the string held tight so that each of the mass is at a distance a from this point P as shown in the figure. Now the midpoint of the string is pulled vertically upwards with a small but constant force F. Okay. As a result, these two particles move towards each other on the surface, and the surface is frictionless here. Neglecting the Earth's gravitation, the magnitude of the acceleration when the separation between them is 2x. Okay. So I will draw here the situation when the separation between these two masses is 2x. So here is the scenario. These two strings are like this, and this is the mass, this is the m mass, and this is another m. Okay, and the length of the string is constant, so length of string is given as a. Okay, along this line this constant force is acting, and distance between them, let us suppose, is 2x. So this distance, half distance, will be equal to x, and this distance will be equal to x. Okay, so because we are pulling this string, there will be a tension force develop in the string that will be equal to, let us suppose it is T, it is also T, and similarly at this end tension is pulling this mass m, and this is also T. Okay, so if I draw here this triangle and I take this angle as the theta, this is also theta. So let us suppose this point is P. If I draw the free body diagram of this point P, so this is our point P, and force is acting on it. One is the force upward, that is equal to F, constant force, and one is the tension force acting in this direction, that is T, and one is the tension force acting in this direction, T. Okay, so since this is the angle theta we are taking, so the components of these both tension forces in the downward direction, that will be equal to what? 2t cos theta, and the horizontal of the tension, horizontal component of the tension force, that will be t sin theta, will be cancelled out. T sin theta. Okay, so these components are cancelled out by each other. So if I write the equation of motion for this point P, since there is not any mass, so upward force will be equal to the downward force. So F will be equal to 2t cos theta. Okay, so value of tension will be equal to F divided by 2 into cos theta. Okay, let us suppose this is our equation number 1. Now if I draw the free body diagram of this mass m, let us suppose this mass is moving in this direction with an acceleration a, and this mass is also approaching the another mass with acceleration a. When the situation is like the distance between them is 2x. Okay, so let me draw the free body diagram of this mass m. So it will be like this: a tension force is acting on this side, that is equal to T. Okay, since in the triangle this angle we are taking theta, so with the horizontal line this angle will be equal to 90 minus theta. So horizontal component of this tension force acting on this mass m, that will be equal to T cos 90 minus theta. Okay, so T cos 90 minus theta means T sin theta. Okay, so this is the force which is providing the acceleration to this mass m. So we'll be writing the equation of motion for this mass m, that is equal to F net in the horizontal direction, is equal to mass into acceleration of this body m. So F net in the horizontal direction is equal to T sin theta, that is equal to m into a. Here T sin theta is providing the acceleration to this body. Now substituting the value of tension from this equation 1, tension is equal to F by 2 cos theta. So tension is equal to F by 2 cos theta into sin theta, that is equal to m into a. Okay, so here acceleration will be equal to F by 2m into tangent theta. Okay, now from this triangle we can easily find out what is the value of tangent theta. This triangle is like this. This triangle, this is the point P and this is the mass m here. This distance is x and this angle is theta. Okay, and this length of the string is given as a. So in this triangle, this side will be equal to root under a square minus x square. Okay, so value of tangent theta will be equal to perpendicular divided by base, that is equal to, here tangent theta perpendicular, that is x divided by base, that is equal to root under a square minus x square. Okay, so the value of acceleration for this particle will be F by 2m into tangent theta, that is equal to x by root under a square minus x square. Okay, so this is the value of horizontal acceleration this particle is having. So our correct option will be F by 2m root under x F by 2m into x by root under a square minus x square, that is option number B.